Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss an introduction to operational amplifier, which is called op-amp. Again, what is the difference between ideal op-amp and practical op-amp? Let's begin. Operational amplifier. The operational amplifier, that is abbreviated as op-amp. OP stands for operational, AMP stands for amplifier. Operational amplifier, op-amp. It was designed to perform mathematical operations such as addition, subtraction, integration and differentiation. These mathematical operations are performed by operational amplifier. These mathematical operations are important in analog computers. All the components of an op-amp are fabricated on a small chip. That small chip we call as integrated circuit, or we named it as IC. Hence, that op-amp is an example of general purpose linear integrated circuit. The circuit diagram of an op-amp, the symbolic diagram, the basic operational amplifier has 5 terminals, 2 input terminals A, B, 1 output terminal C and 2 terminals D and E for power supply voltage. And that terminal A is called non-inverting input terminal, that is called non-inverting input terminal. Why it is called non-inverting input terminal? If a signal is supplied throughout that terminal, then at output we obtain that signal with same phase to that of input. Therefore, the terminal is called non-inverting input terminal. Similarly, the terminal B is called inverting input terminal. Inverting input terminal. Terminal B, inverting input terminal. Why it is called inverting input terminal? If we supply a signal through that of terminal B, then at output we obtain that signal is out of phase to that of input. Therefore, that terminal is called inverting input terminal. This is the symbolic diagram of op-amp. Now that symbolic diagram of an op-amp can be written in form of AC equivalent circuit. The positive, negative, potential V1, V2, output VO, input impedance Z I, output impedance Z O, here is the voltage gain A VD, A VD, VD is the potential difference, that is the potential difference in between these two terminals, that is V1 minus V2. The AC equivalent circuit of an op-amp, operational amplifier. Look here, V1 that is the signal voltage, applied to the non-inverting terminal why it is called non-inverting terminal, as we can understand it as, if a signal we apply to that terminal, then at output we obtain the phase shift as 0, means output signal is the same phase to that of input signal. In mathematically we can show it, and output here V0 is equal to A VD, voltage gain, to that of difference in potential. difference in potential V1 minus V2. In that of situation, we have to prefer V2 as 0. So A times of V1. Why it is called non-inverting? Let I explain it. In that of situation, VO A times of VD. Okay, that is A VD as V1 minus V2. As V2 is equal to 0, then it is A times of V1. If we apply a signal throughout that of V1, then at output we obtain the signal with same phase to that of input. Therefore, we call it as non-inverting. It is called non-inverting as at output we obtain the signal with same phase to input. Therefore, we call it as non-inverting. Next, V2. V2, the signal voltage applied to the non-inverting terminal. Here non-inverting, look here, at output V0 A times of Vd, that is A times V1 minus V2, but here V1 as 0, therefore minus A V2, that is the output voltage VO. Look here, at output it is the negative of AV2, means if we provide a signal through that of V2, then at output we obtain the signal with 180 degree phase shift to that of input. For that reason we call it as non-inverting terminal. At output we obtain the phase shift is 180 degree to input. So it is called non-inverting. Okay. The difference in potential as V1 minus V2, and the power supply, I missed it. So the power supply terminal E and D plus Vs, that minus Vs. E and D terminal are the power supply. the power supply. See the output terminal. And the term A, which is called open circuit gain, open circuit or open loop voltage gain. Why it is named like this, open circuit voltage gain? Look at that symbol. Here there will be no such feedback. Feedback in the sense we don't provide any input from that of output. So that circuit is open, not closed. Therefore, the gain in voltage is considered as open circuit voltage gain. Open circuit voltage gain. Now, by using that AC equivalent circuit of an op-amp, we can easily characterize what is an ideal op-amp and what is the practical op-amp. Ideal op-amp, practical op-amp. Practical operational amplifier. Point we provide for ideal op-amp, the voltage gain, open circuit voltage gain is infinity. Means if we apply a small voltage to that of input, then at output we obtain infinite voltage. It has infinite voltage gain. Voltage gain, that is A is equal to infinity. Infinite voltage gain is possible when the input impedance ZE is the input impedance is infinity, and at the same time output impedance is 0. It has infinite input impedance ZI infinity. Again at the same time it has 0 output impedance. Output impedance 0. The points for ideal op-amp. Similarly, for practical op-amp, the voltage gain here is just around 10 to the power 5 to 10 to the power 6. Here A is nearly 10 to the power 5 to 10 to the power 6. So, the voltage gain is very high. Very high means if we supply a small amount of voltage through that of input, then at the output it is amplified as A times to that of input. At the same time, the input impedance is very high as to that of output impedance is very low. It has very high input impedance it has very low output impedance. These are some important characteristics features of ideal op amp and practical op amp. So, here with the help of that video lecture we understand an introduction to operational amplifier op amp. What is an operational amplifier? Its symbolic diagram, as it is a 5 terminal construction, 2 terminal as input, 1 is output, 2 terminal related to power supply. Its AC equivalent circuit of an operational amplifier, potential V1 V2, its potential difference V1 V2. As we say, the basic building block of an operational amplifier is a differential amplifier. So, it is related to the differential amplifier construction. Differential amplifier indicating that what will be the difference in that of input voltage, that difference in input voltage is amplified at the output. Input voltage difference, input impedance, output impedance, power supply, output voltage, that is the voltage gain. The terminal is called non-inverting terminal, that is the cause. V2 terminal is called non-inverting, sorry, V2 as inverting terminal. V2 as inverting terminal. Why? A is the open circuit voltage gain. Characteristics between ideal op amp and practical op amp. So, with this useful and informative notes, let me wind up the session. Thank you.